What do you mean this is not live? I am live. One second, I will put it on. I need to put it back to charge. Photos, best performance. So this will work it out. I'll have. So am I audible? What do you mean this is not live? Am I audible? Hello. I need to put it back to charge. This went well. Brother, anything. Am I audible? Hello. This went well. Hello. Brother. La di da da. Hello. La di da da. Let's try crunchy audio for a change. If this is not working. Hello. Hello. Hello.
Hello,
Let's try
hello,
crunchy audio
hello,
for a
hello,
change.
hello.
If this is not working.
Audio issues are gonna kill me.
Hello. Hello.
Hello, hello,
Hello.
hello, hello, hello.
Hello. Hello. Am I audible still? Hello. Hello. Hello.
Audio issues are gonna kill me.
Audio issues are gonna kill me.
Hello, hello,
Hello.
hello, hello, hello.
Hello. Hello. Am I audible still? Hello. Hello. Hello.
Audio issues are gonna kill me.
Audio issues are gonna kill me. Sound recorder.
Hello, 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 hello.
Hello. Am I audible still?
Audio issues are gonna kill me.
Audio issues are gonna kill me. Sound recorder.
Hello,
Brother, please.
hello, hello, hello. Audio issues are gonna kill me.
Hello. 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 So is this happening? Hello. 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 Brother. Okay. Hello. Now is this audible? Why can't I hear myself? Brother. What the hell? Okay. Hello. Now is this audible? Why can't I hear myself?
brother.
Okay.
What the heck?
Hello. Now. Is this audible now? The latency is killing me.
Why can't I hear myself? Brother. What the heck?
Hello. Now. Is this audible now? The latency is killing me. Okay, now it's better.
Why can't I hear myself? Brother. What the heck?
Hello. Now. Is this audible now? The latency is killing me. Okay, now it's better. ठीक है, चलो तब शुरू करते हैं आज के लिए. I'll not pay attention to this anymore. This YouTube chat, Chatulita will remain here. I might change the text of scenario, that might be it. Other than that, secondary PC isn't. What do you mean secondary PC? Display capture secondary PC. Wait a second. Display capture. Monitor. Bro, what do you mean? This is my secondary PC. Take care. Ruja. Desktop audio to secondary PC. Look. Display capture 3. I'll make my second monitor my thing. Capture cursor forces. Yeah, I don't know what that means, so that will be my second scene. So either it will be this. Pro. Yeah. So that will be how I'll change my scenarios. Let's keep. Wait, what do you mean? Okay. This is better. This is way better. Yeah. I'll probably not have anyone. This is more of an archive for myself. This looks good enough. Now let's start. Let's remove all the distractions. First, let's have some DMC music. Yeah, this is okay. Lo-fi beats. Music. I actually like Atriok, and that is. Hey, wait a sec. Atriok had a playlist like fuck that you say. Yeah, this is the playlist. Yep, got it. Yep. Let's decrease the sound of this. That will be perfect. Now let's start working on Leetcode problems. Before that, just let me check the CPU utilization. I'm probably killing my computer with this, but sometimes it's a good motivator. So let's start with Leetcode. Please fuck off. I'll go to my roadmap. This is my arrays and hashing. Bro, what? Yeah. Contains to. I'll start from this in my first day of 30 days. I'll probably do coding. till the end of
Now is
days.
this audible? ठीक है चलो तो अब शुरू करते हैं इसकी hey wait please fuck off
I think everything is working. So I'll go to here. One of my challenges that I have, let me just make a G A gaming center. Where the hell did gaming center go? Yeah, gaming center, brother. Gaming center, brother. Yeah, my PC is shite. Nothing can we can do about it. That though. In gaming center also doesn't show up. Okay, that's bad. Okay, that's bad. How does this show up? It still doesn't show up. That's really bad. I thought at least that would show up. Hmm. Okay, let's leave all that stuff behind. My phone, right? I'm giving internet to my laptop. That should be perfectly fine. Yep. Okay, yeah. So this is a contains duplicate. What the? I'm gonna be solving this here, and then I'll probably share my. But that will probably not help because this I'll need to use. No. I need to keep this high, brother. Please, brother, please. I understand it's so good, so fine, but okay. First, let's go. So try to solve this. Given and okay, no, this is actually not helping. Lo-fi should help, I guess. Classical music brought by a deadline. That sounds like a good music soundtrack, but take it. This will have to. Oh, I didn't. I didn't. Bro, what you doing? Please, laptop. Yeah, take it. 20 is duplicate. I'll have a clock. Okay, this was a timer that I was setting. I'll have a 30-minute timer. Each question should be completed in 30 minutes using the solution and everything. After we complete the solution, we'll go back to our initial thing. Okay, yeah. So given an integer of arrays, return true if the value appears at least twice in the array. Returns false if every element is distinct. Okay, so what we want to check here is if we have an array here going from 1 to n. If an array appears twice, we give the output 2, and if the array doesn't, if there is no duplicate elements, we do that. Okay, so here, what we can do is uh, we have probably like 2-3 solutions. The first solution would be the bare bones basic solution that would be like checking each element once and then iterating through it. Let me just go to open paint. Yeah, if I just have to show it perfectly, so it should be kind of like the most bare bones would be like I have 1 2 3 1. I think the stream crashed. I don't know why did the stream crash. Bro, what happened? Brother, what happened? Why did my camera crash? I don't know why, but my camera crashed. This really doesn't happen, never. But my camera has really crashed. Why did it crash? What errors does it show? Oh, wait. Oh, I think my camera is dead. My camera is officially dead. So probably better to just remove this. That would be better. Let's check whether the stream is alive or not. I don't think the stream might be alive. I'll go to my roadmap. Brother, go to live. Oh, I think my camera is dead. Okay, so I think the stream is alive actually. My camera is officially dead. So okay, so the camera has died, but the stream is still going on. So probably better to just remove this. Yeah, got it. So the stream is actually still going on. That's good. So, where were we? Camera, since the camera is up, so we have actually freed up a bit of resources. That would be actually good. So here, so if we have this string here, first we take this as an I, and then we iterate through it till j times, till I minus 1 times. Then we'll find the value. So this will be probably an n square time complexity problem. So this is our initial solution. But is there any other thing given? What are constraints? Oh, we don't have any constraints about that, but let's try to find a better solution here. What might be a better solution? Let's first pro eraser, I don't know, select sizes. Yeah, it was a CRTL plus, right? Ah, this is a so what do we do here is let's take a we can take one thing. uh what is this? Why is this here? Yeah, so CRTLZ, so we can take 1 2 3 1. So what we can do is actually create a hash map. Now we can actually create a hash map. So what we can do is if we divide it and it already exists in the hash map, then it will tell it already exists in the hash map and it will not return something. So first, let's start the timer. Yeah. So cancel. So what we can do is we can create a hash map. So every time it will go, it will push it into the stack at that certain position. Like if you are doing it by position wise. So if two things have the same index, then it will go. Now let me just learn how to build a hash map because I know nothing about this thing, and that's to my demerit, but still what we are doing here is learning, so that is something we need to do. brother brother, you have my mail ID and things, please uh, sign in. I'm not showing any passwords. If I am, then please don't do anything to me, guys. I am innocent. Please. Yeah, we can probably do a hash map. ठीक है. How to create a hash map in Python. Let's learn. Mm, This is probably the best thing. Not a hash table. Hash table, that's okay. So, अबे यार, I don't want to create a function. Hash map string string new hash map string string. You can declare enter div. We can. Abey, yeah, no, not this. Hut. I don't want to do this code, whatever that is. I don't know. I don't know. What a set we can do. That is true. Yeah, this is probably an easy solution. Like set can contain no duplicate. So if it is in that, we return true. That's probably an easy solution. But let's try our first thing once. What is this? Hash map. Asset store hash key. What is this? How about a dictionary actually? Dictionary is a key value pair. My keys have to be unique. So what we can do here is actually so we got nums.list. So we can go a this is getting too short. Bro, what? Zoom. Yep. I'll be able to see what I code actually. Yep. So let A become a dictionary. That's how we define dictionary, right? Probably that's how we define the dictionary, yeah. For I in nums, what we can do is a dot okay. I might seem very dumb right now, but I know everything how to do it. It might seem very dumb to people right now, but this is my first day. Please, I know how to code. I'm just forgetting this. Abey yaar, you're not even showing it. Access change dictionary item is okay. Uh, if a n and if I in a ठीक है. If I in a in this dict then return true. How to add dictionary item? Yes, add dictionary item. Okay, so we can just do okay. It should work though. I'm submitting it. This is a very easy problem. This should not take. In my previous option, I did with the sets, right? Yep. Yep. What was this? This dot add. Okay. Okay. Sets are basically same only, so I can just do. Wait. Uh, kill me, God. This took 10 minutes, but I understood how it's done. So this is can be done with sets or dictionaries. Dictionaries actually take more, so I can just use a dot add x. That should nah add I. I'm dumb. Um, should also work. What happened? How to define a set? How to define a set? Why is it set? Oh. This is a set, yeah. So how to check items in set? Wait a sec. What is happening now? Uh, access items. Ever do some pro access. We can do that. Loops is joins is set method set set dot add we know. So the problem is probably coming at this line. That's what is happening. What is happening? I'm getting triggered. Access set items. Yeah, access set items. If I do that for x in this set, print x. Okay, for banana. Okay. So this should be for I in a. What? It should work. Why is this not working? Dict has no attribute add. I'm not using a dict. I'm using a set. What did I do? Okay. Here I'll probably do this. What I did that will perfectly run. But what did I do in my other challenge? Previous solution that I did. The submissions. I have two submissions, right? What? Uh, what? Uh, I did. Oh, I'm dumb. I'm actually dumb. Okay, got it. So like set requires for us to define it as a set, but for our thing, code, yeah. For this we just what is this? This is a home button. That's why. Oh, I'll kill myself. I'll kill myself. I'll kill myself. This is torture. This is torture. This is really literally insanity, brother, 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 brother. As I was like, how can two things have a same definition? It can't. You dot add I. So I can solve it using both sets and dictionary. So this is solved. This is perfectly fine. Take that's so contains duplicates is an easy problem. Now let's go to our next problem. This is going to be valid anagram. Please don't have the code. I'll kill myself. I'll kill myself. That it doesn't have the code perfectly fine. That's nice. Okay, so valid anagram given two strings s and t. Return true if t is an anagram and what is an anagram? Anagram is a word or a phrase formed by rearranging the letters of a different form phrase using the same letters of the same one. So basically here anagram and anagram, so like the alphabets have to be the same in this. See here the alphabets are not the same, that's why. So what we can do here is we can do one thing. Uh, we can use a stack here actually. We can actually use a stack here. We'll have a stack here. We'll be like we push more or a set here. I can yeah set. We can use a set. We can use a set. We can use a set. I'm dumb. We can use a set here. Set or a dictionary. Anything works here. Again, if A here we have B here, we have C here, we have D here. If A here is perfect, then we move on to the next step. If we have D here, we move on to the next step. If C here, we move on. Perfect. Yeah. So here we have two strings S and T, right? So we have input here. We have an A which is a set. So we go for I in. I think we convert. Hey, bro. J equals to s dot spa. अरे यार s dot split split. I'll come to this. First, let me try my dumb method once. Is at this point I'm trying for ins a dot add I for I in t if not in a. This should work. Yeah, this is as simple as that. It's a set here. It's simple. If it we first just this is linear time complexity because we are using that thing once. We're not going to do because here we can do two methods here. One is we can just see here. One is a bad time complexity where we can do one thing where we can just have a b a and we have b a, so we can just go here, check for NA, that's perfectly fine. Then we go for next, we can check for NA. So that is too much time complexity, we don't use that.
Yeah, what we do is like we have an element we find, we put it into a stack. We have an element we find, we put it into a stack. Oh no, there might be edge cases also, right? Because elements in a stack. Oh no 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 no. Okay, there. Oh no no, my thing. We can't use sets. It'll have an error. It'll have an error, I know. Because sets only allow things to be had there present once. I can just create a list. I can just create a list here. I can just create a list. A dot a p p e n d a p p e n d append. If I not any return false. I a we have something for lists also, right? Lists. Go into it. So valid anagram. Remove list items. Remove banana. That's correct. Remove I. This should perfectly work. I was dumb. Uh, eh? This should be false, right? If I not an I. Oh, okay, got it. It doesn't account for the blank spaces, right? Yeah, it doesn't account for the blank spaces where, yeah, sorry. It doesn't account for when one string finishes. The length is different. Yeah, we can just go if s dot length is not equal to t dot len return false. Yeah, that should be perfectly fine. I'm dumb. Yep. Brother. Yes. How the fuck do I find length of Python strings? I'm dumb. Oh, I'm dumb. I'm actually dumb. Oh, I was till I see till Y, that was T into VS express run. That should work. Okay, I am using too much memory and too much things. So I beat 5% of people. That's bad. Okay, so let's go into something better. Let's think of something better here actually. So I am using list, so that's not good. What else can I do here? Let's check whether my camera is. I think my camera is dead. It's gone for good. Okay, so delete that. ठीक है. So find valid anagrams, right? All submissions. I must have had some previous submission. These are not legitimate. No, Python. Ah, what was? eh, What's C++? This took a year to run. Bro, what is this? That is so okay, that is similar. Count. We are creating two dictionaries of count. Oh, that yeah, I thought of that also. I had that solution. So basically, the thing is, this solution is not purely given here. So here we use a dictionary instead of that. So what we do is here, this solution is how to clear all page. How do I clear the page? Okay. What we do here is we take this, we assign each and every thing to a count. We found count of A, count of T, and we check the counts based on the thing. Do we sort it? I don't think so though. Let's see. Answer. इधर पे आते हैं. This took a lot of time. This was. Oh, this. I'm doing iterations after iterations, right? That's not good. Okay, so the brute force method. This remains same because if length are not same, then it will not work. So what I'll do is I'll create. I'll remove this part. Yeah. So now I'll create two things, two dictionaries. Countess, comma, count t to comma ठीक है. So for I s counts I counts of I plus 1. ठीक है. So from here we get the value of everything present in here. In t Okay, so we get this. So we got the values for both the things. Now, how do we check whether both the things are same or not, right? Okay, wait a sec. We can do one thing like just iterate through one thing. ठीक है. If I go through this, it'll have a dot item set. Val. ठीक है. If count of if val not equal to count t of false. ठीक है. What is happening here? What's that? What? Here A. Oh, okay. Yeah. This is if I in counts of I in counts. Bear, what do you? Listen, sorry. What do you mean? This is what? What? Key error? Anagram. Oh, if it okay, I am doing some major mistake. Let me see my submission first. Is this is getting out of hand actually right now? What have I done here? I have two things: count in, count as range length of STK. So count as dot get as of what is this doing here? I don't know. For counts in for C in counts. Get C 0. Brother, I don't want a solution video. Okay, he has started something. Sorting is like I can just do sorted sets. That's if this is I'm at a very bad state of mind. Okay, hash table, two hash tables, S of I that becomes a key.
Hey everyone, welcome. We want to make sure that the length of strings is exactly the same, because if they're not the same length, then of course it's impossible for them to be palindromes. So we can immediately return false if they are not the same length. Otherwise, we can actually run the algorithm. So let's just go through the strings at the same time. So we can iterate basically through the length of the string s, because we know they're both the same length. So we can just use the index I for both of the strings. Count s is basically we can count the occurrence of each character in string s, of course. So each time we see a character, so a character is basically the s at index I. That's the key of the hash map. Every time we see a character, we want to increment the count of that character by one. So can we just say one plus this? Can we just say one plus this? Well, in Python, no, because what if that character doesn't even exist in the hash map yet? Then this is going to throw a key error, right? Key does not exist. So to get around that in Python, at least, there's a nice little function with hash maps that you can use that's called get. So get this, this key, and it'll basically do exactly what's being done over here on the left side. But the second parameter to this function is basically a default value, so 0.
Got it. That's my mistake happening. See, yeah. So we can't do this in Python. Like unlike here, we can just call that. So if it doesn't exist, we use get function to get around this. That was the mistake I was doing because I was just going around in circles. I was like, how, why? So this was totally unnecessary. So, yeah, here I made sure both of them are same length, so I can just do this. Doesn't matter. See, yeah, for I in range of length of s. Okay, that happens. Okay. Uh, count s of ठीक है कर रहा था मैं so s of I equals to 1 plus count s of I. But we can't do this because if it doesn't exist, then what do we do? So instead of that, we use the get function. So we keep this at one side where we'll get the value, and if it doesn't exist, we put a default value of 0. We do the same thing for t of I 1 plus count t dot get of
t of I comma 0. That's perfectly fine. That's simply lovely. First Chapin had to say it himself. So yeah.
0 is the default value in this case. That means that if this key does not exist in the hash map, then the default value that this function is going to return is 0, which is of course what we would want it to return. So with this method, counting the occurrences of each character in string s, we can do the exact same thing with string t, just by copy pasting this and then changing everything to t. So making sure we use the t hash map and making sure we iterate through the string t, right, t at index I. So that's pretty much it for building the hash maps. Next, we want to iterate through the hash maps and make sure the counts are the same. So let's say for c, for the character in count s, so we just want to make sure the counts of both hash maps are the same. So count at character I is equal to count t at character I. So the counts are the same. Actually, in this case, we want to make sure the counts are not the same, because if they're not the same, then we
Yeah. So it goes to the keys of this. So as here I did it correct only, but I did it twice because what I did here was like for key comma val in countess. This is same only. So this was similar only. Uh, 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 okay, that is my dumb behavior. Not items. This should work. If this doesn't, then I'm just putting one. What? What are you meaning?
basically know to return false immediately, because then we know that they're not anagrams. If you have noticed, we're iterating through the keys in Python, at least we're iterating through all the key values of count s, right? The count map of string s, and c is going to be the key. But what if that key does not exist in the t map, right? Count t. What if it doesn't exist in this map? Well, again, we can use that default function of get, so that it will throw an error for us, and it will return a default value of 0. So that's basically the entire algorithm, right? We built out.
Okay, that is my mistake. I was again going through that method only because if the key doesn't exist, we again use the dot get method. Dot get comma 0. That should be fine. So see, I created two solutions. One was in 10 milliseconds. And this was brute force method. I was like, not equal, then just append through each list if it is not present in the list view. Second was much more better. I used, they call this a hash map, I call this a dictionary. It's what you want to call it. So first we check the lengths are not equal, then we return false, then we create two dictionaries or hash maps in what Leetcode calls it. I call it dictionary because that is simpler for me. So then we know since the length of both are same, we can just iterate both through both once. So we can just say for I in range of length of s, so we'll go from 0 to n minus 1. So we just put the values of s of I, the first index of the nth index key. We make that as a key, and then 1 plus each time it is present or already has been repeated. Initially we have here we use the get function here so that if there is the key is not present already, we give a default value of 0. Similar thing while so that happens after it. In checking we do this, so we just call a key value pair and we are told the items, like we iterate through the dictionary. If the value is not equal to the get of key, return false. That's perfect. That happens.
That's how we perform our anagram. So So then if the loop exits, we can go ahead and return true. That's the entire code. Let's run it to make sure that it works. So you can see on the left it does run. It's relatively efficient, though it doesn't reflect that on Leetcode. But basically, you can actually do exactly what I just showed you with one line of code, at least in Python. But I think it's cheating and it probably won't work in an interview. But counter is a data structure in Python, which is a hash map, but it basically counts things automatically for you. So we can run a counter on S and we can run a counter on T. And if these counters are exactly equal, basically by doing the equal sign, just doing what I did down here right with the for loop, the equal sign does it for us instantly. So it does that, and then we just return the result. If they're equal, it'll return true. If they're equal, it'll return false. We'll run that and make sure that it works, which it does, and it's actually slightly more efficient, I guess. The overall time complexity and space complexity of both of these solutions is exactly the same, just this takes more lines of code because we're actually explicitly writing out all the operations. So now, what if as a follow-up question, your interviewer asks you, how can you make a solution where we don't actually need extra memory? Can you do a solution with O of 1 memory? How would you solve that problem? It's a good question, and the solution is actually simpler than you might think. Just kind of thinking about how anagrams work. If you took all of these characters and put them in a hash map where we can count the occurrences, then it's pretty easy to check if they're equal. But isn't there another way? What if we made sure that the characters show up in the exact same order every single time? What do we mean by order? Well, one possible way would be sorted order, right? Because if they really are the exact same characters, then if we put them in sorted order, then they should actually become the exact same string. Then we can literally just do an equal operation on both of the sorted strings and guarantee that they're going to be equal. But the downside is, what's the time complexity of doing sort? Well, in some cases with bad sorting algorithms like bubble sort or something, it might be n squared, right? Good sorting algorithms can do it in n log n time, right? Worst case, they go n log n time. But you know, the
Not
kind of
sort,
usually
yeah.
sorting algorithms, at least good ones, actually do use extra memory. They use O of n extra memory, but sometimes they don't. Sometimes they can be really optimized and actually run on constant memory, constant extra memory. It will depend on which built-in library function you're using, but usually for some reason interviewers just assume that sorting doesn't take extra space. So it's definitely something to discuss with your interviewer. Yeah, so basically if you just sort it, it solves the problem for you, right? 'Cause if we took anagram and we sorted it, we get AAA, G, M, N, R, right? It'd be the same order. And if we take this string T, sort it, it's the exact same characters, so when we sort it, it should be the exact same string, and it is. So now let's get into the code of this solution. Okay, so now you can see these were the two solutions we originally came up with. Now let's do the third and final solution. We can just run the sort function on S and the sort function, the built-in sort functions at least in Python on T as well. And if they're exactly equal, it'll return true. If they're not equal, it will return false. Let's run it to make sure that it works. And on the left, you can see yes, it does. It's relatively efficient, but technically it's not as efficient as the two previous solutions that we came up with below. And who knows, maybe your interviewer will actually want you to write out your own sorting function for this. So I really hope that this was helpful. If it was, please like and subscribe. Support the channel a lot. And check out my Patreon where you can further support the channel. And hopefully I'll see you pretty soon.
Oh, here he just creates pro. I'm happy with this. So I solved these two problems. Let's go to our two sum problem now. What's the time actually? It's 5 o'clock. Okay. By 6 o'clock, I'll at least have like 4 sums finished. Yeah. Okay. Given an array of integer nums and an integer target, return indices of two numbers that add up to the target. Okay. You may assume each input would have exactly one solution. You may not use the element twice. Okay, 7 and 2, 9. Okay. So, one thing is if the element is greater than the target, then we just discard it. Okay. Yeah, 4 and 1 and 2. Okay. What can I do here? It's two sum, right? रुक जाओ. Let's see what can I do here. Okay. So we have 1, 7, 8, 11, 15, 29. So we have a number here, 9. If it is greater than this, then we just leave the shit out. We have this here, and we have this here. We can, since it's sorted, we just take this, but that will take a lot of time. What can we do here? Listen, what we can just subtract it and check whether this is present in here. Oh, that's actually a good idea. So yeah, first we can do two things. Yeah, so we can do two things here right now. One would be, yeah, see, I have a total big list. I have sorted this list into two things, this thing and this thing. If this is greater than this, then we remove. If it's lesser than, then that's perfect. Then from the smallest element, what we do is we subtract it and we check whether that subtracted element is present or not. If that is not present, then we move on to the next one. Let's try that once. ठीक है. Nums right. एक second, one second. CRTL Shafty. Leetcode में ही यहाँ solution खाया डाला. I'm seeing the solution for valid anagram because I needed the sorted function. I forgot how that works. At sorted as okay. I just do sorted, then what happens? Least. How do I sort this? Dot sort भी काम करता है. These guys try to make everything. Nums dot sort. ठीक है. List methods. Let's create a for loop because it's for loop. So 2, 3 for loop doesn't matter. For and try both ones. I in nums if greater than target nums dot pop. Hi, that's perfect. Dot equals to target minus I dot and nums. I've written the positions right. Right. J. It's J F dot enums. Oh, brother. How do I solve this? Let's check my YouTube stream because I'm getting bored. I'm not having an epiphany. I should be live, right? If I'm not live, I'm gonna be really. Um, your channel. I'm in range of not equal to the get of key return false. That's perfect. That happens.
After we perform our data. So then if the loop exits, we can go ahead and return true.
11, 15, 29. ठीक है. This channel looks okay. How do I find the position? Let's see. Is open number of elements with the specified value. Okay. Extend, insert, pop, sort. Um, okay. Using a if statement. See, I'm totally dumb. Are you guys sure? I'm not importing numpy. I'm not dumb. Uh, That's range. And what? Why I can use NumPy, but that's like using libraries, and that's cringe. No, that is far-fetched. Well, that's cringe. Okay, the hint told me to use a hash map, basically a dictionary and stuff, right? So, what can we use a hash map for here? So, let me think about it once. Okay, we can make it so that the index becomes the keys and values becomes our things. Okay, okay. We can do one thing is how do I extend this? Okay, so here what we do after this is we create a hash map where the index becomes our keys. I don't care about the time. Index becomes our keys and the values becomes our values. After sorting we do this. After sorting we do this 4, 5, 9. Sorting we do put it into a hash map. Now if we present in it, so since this is present, we know the key also linked to the hash map. So after sorting, we do that what I just wrote, we do that also. Nip equals to, I don't do a hash map. That take it. So that here I define another for loop for I, j enumerate nums. So from here I get the key of the first one. Next second, if dot is in Nice. Return, तो I can't return anything. Mob equals to. Ouch. I can return. I actually can return. Wait a thing. Can let me just first return I comma dot. This is probably gonna be wrong. I know this is probably gonna be wrong, but still. Index out of range. What? What? What do you mean index out of range? Okay, first इस टू में क्या गलती हो रहा है? 1,2 right? Target minus Jia, so how is it returning 0? It cannot return 0. How? I can't. Help. Help. Array. Solution browser.
Let's solve Leetcode 1 2-sum, the most popular Leetcode question. So we're given an input array and some target, in this case 9. And we want to find the two values in this input array that sum to 9. So in this case it's 2 and 7. Now we want to return the indices of these two values. So the index of 0, or the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. Now the most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So we start at 2, we check every combination we can make that includes 2. So we scan through the remainder of the array 1, 5, 3, and check if any of those numbers added to 2 sums to our target 4. In this case, none of them do. So next we can repeat the process. Let's check every combination including 1 that sums up to target 4. So we scan through every element that comes after it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that the overall worst case time
N
is equal to
square,
n
yeah.
squared. So can we do better? Now the thing to notice is that for each number, for example 1, the value we're looking for is the difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that will equal the target. So we don't have to check every number. We just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So let's
Yeah, I
mapping
thought
the
so.
value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map, and we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. We can't use the same value twice, so we would have to compare the index of our current 2 with the index of the 2 that's in our hash map. There's actually an easier way to do this though, and it's a little clever, and let me show you how to do it that way. So doing it this clever way, initially we say our hash map is empty. So we get to the value 2 first of all, right? And we want to look for the difference 4 minus 2 in our hash map. Our hash map is empty, so we don't find 2. So then after we visited this element, then we can add it to our hash map. So now that I'm done visiting it, I'm going to move to the second element 1. Before I do that, I'm going to add this value 2 to our hash map, and the index of this value is going to be 0. Now I'm at 1. I'm looking for 4 minus 1, which is 3. I see 3 isn't in our hash map, but it actually is in our array. So what's the problem? Well, for now we're going to say we don't find a 3. So we add 1 to our hash map. The index of this 1 is 1, and now we move to the next element 5. We check does 4 minus 5 exists in our hash map. That's negative 1, so no, it does not. Then we add this 5 to our hash map, and its index, which is 2. And we move to the last value in the array, 3. We check does 4 minus 3 exist in our hash map. Now that's 1, so we see it does exist, right? Right over here. The value exists, and its index is 1. So now we found our two values that sum to the target, and we want to return their indices, which are going to be 1 and 3. So with this algorithm, we don't have to initialize our hash map. It can be initially empty, and then we can just iterate through this array in one pass. Now the reason the algorithm can work in that way with just one pass is this. So let's say we had a giant array, right? But we know for sure that there are 2 elements in this array to our target, right? We don't know where they are. They're at some arbitrary location. When we visit the first one of those elements, our hash map is only going to be this portion of the array. It's only going to have the values that came before the first value. So we're going to notice that the second value that can sum to the target is not going to be in our hash map yet. But once we get to the second value, our hash map is going to be this portion. So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map. So we're guaranteed to find the solution. Now since we only have to iterate through the array once, and we're adding each value to our hash map, which is a constant time operation, and we're checking if a value exists in our hash map, which is also a constant time operation, the time complexity is going to be big O of n. We are using extra memory, right? The hash map isn't free, so the memory complexity is also going to be O of n because we could potentially add every value to the hash map. So now let's code the solution. So remember we need a hash map, right? I'm going to call this previous map because it's basically every element that comes before the current element. Every previous element is going to be stored in this map. We're going to be mapping the value to the index of that value. So now let's iterate through every value in this array. We need the index as well as the actual number. So let's do it like this in Python. Before we add this to our map, let's check if the difference, which is equal to target minus n. Now let's check if this difference is already in the hash map. If it is, then we can return the solution, which is going to be a pair of the indices. So I can get the first index like this, and the second index is just I. Now if we don't find the solution, then we have to update our hash map. So for this value n, I'm going to say the index is I, and then we're going to continue. Since we're guaranteed that a solution exists, we don't have to return anything out here, right? But I'll just put a return for no reason. Now let's see if it works. And it works.
Yeah, so in this what we do is we take our hash map, we create a hash map. Talked about this, we create a hash map. My value and index, okay. So initially I have a 3 2 1 5 3 minus 4 मैं check करूँगा. So 3 minus 4 1 does it exist? Does not exist. We enter 3, we enter 0. Then we 2 minus 4 does it 2 exist? Does not exist. Then we enter 2 and 1. Then we enter 1. 4 minus 1 3 exists, 3 exists. Then enter return true. ठीक है. So previous map, if in previous map, of diff. Okay, this is okay. I got somewhat close to the end of the date. This one, but I was doing sorting, bro. I was going too much deep, trying to. It's as simple as fuck. D. Take care. E dot in D return D dot comma I D dot equals to I. Yeah.
Works perfectly. So with this kind of neat little trick with just doing it in one pass, you can
उल्टा होगा इसका आंसर बट स्टिल
reduce the amount of code you have to write.
okay, what the fuck did I do? Brother, what the fuck did I do? What? Second case edit? ठीक है, so I'm doing something dumb. What did this? And हाँ ठीक है, oh नहीं, this I did that only. If dip in return, otherwise data. If dot in dict remap return dot and remap. हाँ ठीक है, I comment J in that, and this is target now if diff dot indict Return that command.
We don't have to return anything out here, right? I'll just put a return for no reason. Now let's see if it works. And it works perfectly. So with this kind of neat little trick with
Brother. Brother, what the fuck, brother? Unpass. Brother, what the fuck, brother? This was the fuck do you mean this? ठीक है, these two are same lines. These two mean the same thing. That's well and good. These two also mean the same thing. Yeah, so no, I can just tell it to fuck return. How? See, this is literally the same input. This is literally the same input. How? Am I blind? Target minus n, yeah, target minus n. Let's do one thing. Let's make this n. This will also become n. That's perfectly fine. Oh, I'm fucking dumb. Oh, fucking dumbass. It's not duty. It's fucking J, mate. It's fucking J. It's all this J. Yeah, it's doing J because based on that. What is the difference? Because you didn't find the difference. Oh, fuck me. Yeah, let me tell you what happens. So, in here, what we do is we create a dictionary. In this dictionary, we have our keys as our values and our values as our indexes. So, this is basically a val slash index pairs. Okay. So, we have this and we are going to find the indexes. So we enumerate where I becomes our index and j becomes our value. So we find the TOT, this I figured out by myself. So here we have all the other elements. If we subtract, so first we do is we take the element, we subtract it from the target. If that is present in our dictionary, then we just return the dictionary's element and the initial element to the guy, and that's the answer. But if it is not, then what we do is we insert the jth element into the dictionary, we push it into the dictionary, and then we an index also. That's perfectly fine. That's done. Okay, so this done. What is group anagrams? Let's do group anagrams now. 4 programs for my puny brain is enough. After this, I'll do GRE lessons. I don't think so I can show GRE on stream, so I'll not do that probably. So what's this? Given an array of strings, group anagrams you can return in any order. So bat, eat, tea, crab, eight, nut. Okay, there's nothing. So 80, 80. So what we can do here? Okay, I can do it with normal anagrams. So did it with normal anagrams? Yeah, I did that. But I didn't need to do it with everything. That why would I do it? Yes, I can just say. Okay, so what I can do here is okay. Actually, I don't feel like doing M3